Hi everybody, welcome to section 8.5b. In section 8.5a we talked about how to factor two terms and find the greatest common factor. So you're going to see a really common theme throughout this whole chapter, which is finding the greatest common factor. So I've got a couple examples. Excuse me. A couple examples right here at the top, because notice everything that we did in 8.5a had two terms. We were factoring binomials. Well, we're going to do the same thing for trinomials. At the beginning here, we're still going to find the GCF to begin. Then we can look at what's left as we move through the chapter. So notice practice number 1, we've got a trinomial, 15x to the second plus 25x minus 20. I notice that only two of the terms have x's in them, so I know an x will not be a part of the GCF. What number goes into 15, 25, and 20? You could do your prime factorization if you want, what gets circled in each. I'm going to start just doing, let's think about this. I believe that 5 is the largest number that goes into both of those. Please notice, since I'm starting with a trinomial, I should have the GCF and then a trinomial inside my parentheses for my leftovers. Think distributive property or division. 5 times what will give me this 15x to the third? Sorry, 15x to the second. I was thinking 3x squared. 5x times what will give me this plus 25x for my second term? It will be a positive, right? We talk about how everything needs a sign. 5x. And 5 times what will give me that last term of negative 20? It's going to be a 4, and that 4 is going to be negative. So my factored form for this trinomial is 5 multiplied by the sum of 3x squared plus 5x minus 4. Right? So that's how we do it, exactly the same as what we did before. So nothing's changed for that trinomial. When we get into section 8.7, we'll talk about looking at those trinomials. But that's what we're going to do. So for number 2, I've got a 15a to the second b to the second minus 10a squared b minus 20ab. First of all, you want to look at numbers or variables first? Numbers first. All right. So this is purely coincidental, but what goes into a 15, a 10, and a 20? Feel free to go ahead and do a prime factorization if you want, but I'm thinking we've got a 5 again for our GCF. However, are there any variables? If you think about writing out 15, I'm going to just do this, I guess, so that I can make sure that you see where I'm getting this from. Would you agree that 15a squared b squared is 3 times 5 times a times a times a b times b? And a 10a squared, actually a negative 10, a squared b is negative 1 times 2 times 5 times a times a times b. And a negative 20ab, oops, negative 20ab, let me try writing that again, 20ab. If I do a little factor tree here real quick, 4 times 5, right? 2 times 2. So I'm saying that's going to be a negative 1 times 2 times 2 times 5 times a times b. So my first question is, does everybody see why 5 is the number part of my GCF? Right? I've got a set of 5s right here. No other numbers go into all of them, but what about variables? I've got a set of a's and I've got a set of b's. So what will my GCF be? 5 times a times b. So 5ab goes on the outside of those parentheses. Now, if you're thinking distributive property or leftovers, I'm doing one each way. Notice in this first line right here, what are the leftovers or the things that did not get multiplied? Got myself a 3ab, or 5ab times 3ab would give me that 15a to the second b to the second. What about in this second line? What do I have left? Negative 1 times 2 times this a right here. That's not marked. So minus 2a. Or 5ab times negative 2a would give me a negative 10, a to the second b. And last but not least, in this final line right here, what do I have left over? A negative 1 times 2 times 2. Well, I believe that's going to be -4. There are no variables left uncircled, so I have no variables. And it makes sense, right? 5ab times -4 would be -20ab. So factor those the same. It's just more to keep track of. If you like prime factorization like we did with example 2, feel free to do so. If you can do it mentally, or maybe a mixture of the two. So, but now I'm going to throw more terms into the match. So we've talked about 2 terms, GCF, 3 terms, start with your GCF, 4 terms. When we have 4 or more monomials, we usually can only factor by grouping in pairs. We're going to group those guys. Our grouping symbols in math are parentheses. So we're going to put a parentheses around and make 2 pairs of factor problems. So to factor by grouping, group them in pairs. Use the commutative property if needed. Everybody remembers commutative property, right? Commutative property says you can change the order and rearrange things. Sometimes you might need to. Sometimes you have better factors, or there's no x's in the, or whatever. Once you've grouped them by putting parentheses around them, so pair of parentheses and a pair of parentheses, you're going to factor each pair separately using the GCF. If you don't know this about me yet, I like to sneak in 2 problems in one. So here's how we're going to do 2 problems in one. And last but not least, after you've done 2 GCF problems, so you got your GCF on the outside, your leftovers on the inside, you're going to look to see if you have common factors or a repeated parenthesis. And we'll do a couple examples so you can see those, because once you see them, you're going to go, ah. So we'll make sure we do a couple. So let's start off with, we've only got 3 examples. Let's do 1 and 5, and we can talk about 4 after. I'm sorry, 4 and 5. 3 and 5, I got this. So factor each polynomial. Notice, first of all, how many terms are there? Everybody agree there's 4 terms, right? 4ab, an 8b, a positive 3a, and a positive 6. So 4 terms, which means we're going to group them 2 and 2. So when I say group them, I'm talking about actually putting parentheses and making 2 problems. Ignore the first problem. I'm sorry, ignore the second problem. Focus on the first problem. If I've got a 4ab plus 8b, what is the GCF for those 2? What's the largest thing that I can take out of both? 4 and 8, I believe a 4. And notice how there's b's in both of them, so I could take out a b. If you want to list that, 2 times 2 times a times b, and a would be 2, 2, 2, and a b. So you'd be able to circle a couple of 2's and a b. So distributive property, 4b times what will give us 4ab? All we need is an a, right? 4b times what will give us 8b? I think that's just going to be a 2. Halfway done. So now ignore that first half, everything that we've done. Just look at the second half, 3a plus 6. So what's the GCF for a 3a and a 6? I've got 3, right? And what kind of 3 is it? You know, I keep saying everything has to have a sign. Make it a positive, make it a positive 3. And if you're thinking distributive property, 3 times what will give us that 3a? 3 times what will give us this 6 right here? And what kind of 2 is it? Positive. Now, I hope there's bells and whistles going off in your mind right now, because notice when I said to look to see if you've got common factors, notice that parentheses got an a plus 2, and that parentheses got an a plus 2. This is a good thing. We like it when they both have a plus 2's, or whatever it might be. So what we're going to do is we're going to have 2 parentheses next to each other. Your answer will look like a FOIL problem or distributive property, or draw those mental lines. One of your parentheses will get the repeating a plus 2. The other parenthesis comes from your GCFs. So I've got a 4b plus 3. When you get it down to 2 parentheses being multiplied, you have got yourself a final answer. So the repeated stuff goes in one parenthesis, the GCFs go in the second, and I want to make sure I mention it doesn't matter what order they are in as long as they are both part of your answer. So you can switch them around. You could have the A plus 2 first, or you could have the A plus 2 second, as long as it's in its own parenthesis. Right? So let's skip this one. Let's do number 5. 5's kind of a sneaky one. So number 5, notice how many terms we've got. Does everybody see 4 terms? 15a, a negative 3ab, a positive 4b, and a minus 20. So we can rearrange if we want. We can keep it the same way if we want. If you see something that says to you, oh, rearrange that, go ahead. But you don't have to. You could just go from where you're at. So I'm going to put parentheses around both halves. I'm going to block out the second half, and I'm going to ask you the question, what is the GCF for a 15a and a negative 3ab? Well, number-wise, just a 3, right? Variable-wise, would you agree with an A? So 3a times what will give us that 15a? Just a 5. 3a times what will give us that negative 3ab? So a negative b. We've already got the 3 and the a. Everybody okay with that? If you're struggling with this, please make sure you ask, because this is going to come around again and again. So the second half of the problem, I've got a 4b minus 20. What's my GCF for a 4b and a negative 20? No variables, but would you agree with a 4? And remember, put a sign there. It's a positive 4. You may now know that I have to have a sign there because those two guys are going to become their own set of parentheses. So when I divide both of those by 4, or think 4 times what will give me that 4b, I've got a b. 4 times what will give me that negative 20? A 5 that is negative. So now I can look to see, can I highlight like I did on the last problem? Do I have identical parentheses? So close and yet so far. My first parenthesis is a b minus 5. My first parenthesis is a 5 minus b. My second parenthesis is a b minus 5. They're close, but not quite. What do you notice about the signs on a 5 minus b and a b minus 5? The 5 in the first parenthesis is positive, 5 in the second parenthesis is negative. The b in the first parenthesis, negative, right? What about the b in the second parenthesis? Positive. How do I switch it so that my signs are exactly the opposite? Think of the second half of the problem. How could I make this b become a negative and this 5 become a positive? I would multiply by a negative 1, right? So this 4 is going to become a minus 4 instead. So now, even though I don't have them written in exactly the same order, my b's are negative and my 5's are positive. So now I can write my 2 sets of parentheses. One set of parentheses will be my repeated stuff, and I could put it in either order as long as my 5 is positive and my b is negative. You could say it as negative b plus 5. What goes inside my other parenthesis? Remember, that's going to be my GCFs out here, which means that I'm going to have a 3a plus a negative 4, or 3a minus 4. That was a tricky one. Watch those ones. I wanted to make sure we did that because I want to point out that they must be exactly identical signs. We could switch the order on them and say negative b plus 5, but my b is negative and my 5's positive. So my answer for this is 3a minus 4 and a 5 minus b, or you may have written it as a 3a minus 4 and a negative b plus 5 if you like that better. Remember, your answers look like 2 sets of parentheses that I would usually say go ahead and do distributive property or FOIL. All right, so lesson summary. I got something in there. Are you allowed to rearrange the terms before grouping into 2 pairs if you've got 4 terms in your polynomial? Why might that be helpful? What can you think of why you would want to do that? And practice problem. I've got a 4-termed problem for you. 2xy plus y minus 4x minus 2. So remember, 4 terms, group them into 2 and 2. I would be really careful on the sign for my second GCF. Watch that sign for your second GCF. All right, see you next time for 8.5C.